And one which I believe has a big potential to grow and to be a very important part of that energy mix is then the tidal energy. And for us, it's then a dual purpose. It is according to our own sustainability targets, but also others, our customers and other companies will have a greater ability to access renewable energy if we are a part of growing tidal energy in the world.
Thank you, Annika, for joining us. And as the world accelerates its shift towards sustainable energy, innovative technologies are emerging from some unexpected quarters, and one such breakthrough is taking place beneath the waves of the Faroe Islands, where a tidal energy project, which is being likened to a space program beneath the sea, is capturing the attention. And at the heart of this venture is SKF, a company long renowned for its cutting edge bearing technologies. And now it's applying its engineering expertise to help harness the moon's gravitational pull through a groundbreaking system known as the lunar tidal kite. And to explore how Escape is helping shape the future of marine renewables, we have with us Annika Ölme, Chief Technology Officer and Senior Vice President of Technology Development at SKF. Thank you, Annika, for joining us.
Well, it's great to be here, so thank you for having me.
Great. So, tell us about this project first. And, we all know SKF as for its innovation in bearing technology. So, how come and what inspired the company to, move towards tidal energy project, which we, as I said, that we are, likened to be the space program of sea.
Yes, so I think it actually goes very much back to the roots of SKF. Already when the company was started in 1907, it was based on solving a customer problem. The textile factories around Gothenburg, they had problems of sparks and really fires from the rotating equipment. And SKF was started by solving that customer problem. So I think in our DNA has always been that we are the experts of rotating equipment of the bearing technology, but we always do that with a customer problem in mind. And actually, in this case, an opportunity to harness renewable energy coming from tidal forces from the moon is of course an opportunity. So there's innovation needed to be able to harness this energy. And innovation in this case is very much around rotating equipment. I mean, really what you have is a kite that is flying in the water like this, and it allows a propeller to turn, and that propeller, that needs to work perfectly. The rudders of this kite need to work perfectly. Everything is rotating here. So that is where our technology expertise comes into play, where we can together with a company like Minesto in this case, we can work together on the best design, to get the best rotating performance out there. So for us, it is, I would say, work as usual, but we also really are very excited about our own sustainability goals, about the sustainability moving the world forward. And innovation like this is needed to move that forward.
Yes, now I can understand with how you explain the rotating, the machines that are required, where your expertise come in, and I can only imagine the beautiful sight it would be to see the machines working in at tandem over the sea. So, how does SKF's participation in the Faroe Island project, how does it reflect the long-term sustainability goals that you have?
Mm. So our sustainability goals are very important to us, and one of the goals we have is, of course, to have a net zero in scope 1 and 2 in 2030. 2030 is coming close, right? So we are very dedicated on that. We are actually well on track on achieving that. And just as a kind of interesting information for you also, actually in India, we are a little bit, ahead of the plan. So we will actually accomplish this a little bit earlier, which is great. But we also have our scope 3 up and downstream targets for 2050. And scope 3 downstream is, of course, allowing our customers then to really reduce their environmental impact in the end. So working with one of the most important things for us to achieve our own sustainability targets is accessibility to renewable energy. Renewable energy is, of course, you have wind power, there is a number of different types of renewable energy, and one which I believe has a big potential to grow and to be a very important part of that energy mix is then the tidal energy. And for us, it's then a dual purpose. It is according to our own sustainability targets, but also others, our customers and other companies will have a greater ability to access renewable energy if we are a part of growing tidal energy in the world.
So having said that, what are the most challenging engineering requirements, when you're doing this kind of uh, uh, huge project, and that too in a sea which is kind of unpredictable, and especially, the underwater environment is variable and it doesn't remain the same.
Now, there's a couple of challenges that stand out in this particular application. I mean, I would say three things. So the first one is, of course, that it's a new type of design. We are exploring the boundaries of technology. And of course, that means that we have to iterate, we have to work very closely to the customer to make sure that we go into this unknown territory of this application design together with all of the knowledge we have and our customer Minesto has. The second one I would like to mention is, of course, the seawater, the salt water that is in the environment of this fast-moving kite. You've seen how it moves in the water. So that means you have to really protect the application from having salt water coming into the rotation core. And that means that you have to use sealing technologies and really advanced ways to stop the salt water of entering into the system. Again, you have then the kind of new edge of technology where you have to be extra careful in your design, where we have a lot of testing together with the customer as well. And then you have the notion of the salt water and really protecting the equipment, and then ensuring that you have the long lifetime and the low friction so that you can really have a functioning equipment and good maintenance conditions for that application. So those have been some of the key engineering challenges that we have been working on.
If it becomes costly, then the entire purpose of having renewable energy, which can be used at scale, will be defeated. So that's very
Absolutely.
important. So, how do tidal conditions impact this calculation, and how does this data guide your design decisions compared to other traditional applications?
No, and I think every application is unique. What is sometimes very different is how much do you know about the application? How long has it been around? How certain can you be about the load conditions? How much do you know about the friction and the total performance of the system? And of course, in innovative areas like this, we know less. So that means that we need to use digital tools to predict how this would perform. So it's very, very important in areas of innovation that we have this, all of the knowledge over all of the years built into our digital tools that can really help us to predict what's going to happen. But I would say in this case, you talked about it's both about the bearing life, but also about the emissions. If we take the life then, for example, here we have to understand what are really the load conditions on this application. As it flies through the water, what are the loads that actually affect this whole system in this instance? So by using good level and good quality of loading data into our calculations, that really helps us to perform very accurate calculations of the future. The other part is then the CO2 part. And here we're working with predicting what will actually the friction be of this system. We are a company that fight friction, and we know that 20% of the world's energy is lost in friction, really. Imagine that we have a renewable energy source. If we can minimize the friction, the actual energy that is entered into the world energy system will be increased. So we have here a great opportunity to, make this into a very efficient energy production system. And also by being able to predict the friction and the actual CO2 usage in the application, it helps us to actually make a much more efficient energy solution.
So, I know the innovation is an ongoing process, Annika. But since you started probably. Until now, where you are, what do you think? How do you see the innovation on a scale of say 10 where you are? I know it cannot end because innovation is every day, but if it has to be, point to point, how do you see, and how have the available applications helped you in devising what you're thinking of in the future?
No, I think we see that innovation happens in different areas. I mean, some innovation really helps us to strengthen further our core products that we have had for, in some cases, 100 years. The thing about the bearing technology is that actually we're still finding big leverages in increasing the performance of our traditional core products through innovation all the time. And that happens through, material science, understanding steel better, understanding the design of the bearing. You can always perfect that more. We can use, different types of materials, different types of designs. But we also become a lot better at predicting lifetime and understanding all of the data that we have through AI and other tools, which allows us to actually make much better calculations and predictions than we could some 20 years ago. So a lot of our innovation is really, to harness and improve our core. But also, we can see then more innovation that we are bringing in that are more disruptive or that are more bold innovations. And there, for example, the filter technology that we acquired some years ago, which allows us to filter oil on a nano level, which means that any production facility does not have to buy new oil ever again. That is also bringing a different offer to the market. It's not really in our core bearing offer, but it's really, putting our intelligent and clean strategy to life by bringing also some new things to the market. So I would say it never stands still. I think it's the same in the energy industry, right? It never stands still. There's always new technologies and things coming along, with hydrogen and tidal power and wave power. And we are just a big part of that, and driving that from our angle.
Yeah, yeah. Every day you wake up and the technology has moved forward. That's how it has been for us for quite some time now. And thank you for joining us today.
Thank you. It's been a great discussion, and I wish you a great rest of the day.
Thank you. How can India's engineering and the entire manufacturing ecosystem can contribute to the development and scaling of advanced tidal energy technologies, which is quite a new field as of now?
Yeah. No, I think firstly, India is, we're expected to be a $5 trillion economy in the next 3 years, and probably 7 trillion by 2030. So we're going to be the third largest economy. So it's no longer an option. We need to play a big role when it comes to large infrastructure and sustainability projects if we have to make a dent in the world. Now, when it comes to capabilities, there are two capabilities, right? One is from an engineering perspective, and we've got a pretty strong, marine engineering capability in India. So, if you look at things like offshore installations, if you look at undersea cables, etc., we've carried out a lot of these large-scale infrastructure projects so that know-how is available with us when it comes to pure offshore infrastructure. When it comes to manufacturing and it comes to tidal energy, and let's say it comes to underwater turbines, etc., again, we've got a pretty strong oil and gas sector, right? Where again, we do offshore work. We have that capability and the ability to manufacture this kind of equipment. So it's really about adapting these skills that we already have in the country. It's not brand new, but it's about adapting these existing skills and technologies that we have and using them for a different purpose in environments that are not completely new for us, because we're doing this when it comes to marine and oil and gas already.
Yeah, correct. So we have a huge coastline, and this kind of projects definitely. And you talked about the size of the economy. Let's also talk about the population that we have, and if we can secure this kind of energy, that will go a long way in making us really sustainable, I believe. And our coastline is around 7,500 kilometers. So what are the most promising regions in India for these implementing these tidal energy solutions, you think?
Yeah, no, that's a good point. I think one is just the pure 7,500 kilometers that you mentioned. But I think more importantly, we've got about 40 gigawatts of tidal capacity along our coastline, right? And, like you said, it's a long coastline. So we've got the Arabian Sea, we've got the Bay of Bengal. But I think when it purely comes to tidal energy capacity and potential, we're better off on the Arabian Sea, right? So obviously that brings us to states like Karnataka, Maharashtra, Goa, which would be preferred. On the other side, of course, we do have potential, but it is less energy dense as compared to Karnataka, Maharashtra, Goa. I think another point for us to kind of think of is also the Andamans, because one of the things that's unique there is we've got cold water, right? So that also gives us the unique environment where we can also have ocean thermal energy projects running in conjunction with tidal energy. So I think these are a couple of areas which could give us a lot of upside.
Of course, I forgot. I think I forgot about the other islands also that we have, which can also be probably tapped in the coming future. But what are the other specific challenges and also opportunities you foresee in customizing SKF's solutions for these unique marine and coastal conditions?
Yeah, I'll start with the opportunity, and I think the opportunity is that it's pretty much untouched right now, right? So it's all for the taking, and everything that we get would be additional. On the challenges, the real challenge is the environment. I mean, it's a challenging environment. It's not that it's a challenge for us to solve. So take, for example, it's by definition, it's coastal, it's seawater, so it's corrosive, right? So the
Right.
environment in which you operate is going to be corrosive. Secondly, these are not easy to reach places. So it's not like a land installation where you could go and do easy maintenance and frequent maintenance. So that's the second challenge. And I think thirdly, also, you have very dynamic high loads because of tidal energy, right? So it's not very consistent. It could be very high load and it's a very high dynamic load. So it's very different from an application perspective in terms of what you would see in a regular motor or a regular pump, where you've got very predictable loads, very consistent loads. So these are the few challenges that we have. But having said that, we've done a lot of work globally in SKF and oil and gas, for example, on offshore platforms and also in some of our marine projects. So I think for each of these challenges, we have solutions. So, for example, for the corrosive environment, we've got specialized material that we use. We've got some bearings for called spherical plane bearings, for example, where they're completely maintenance free, right? So you don't need someone to go in and maintain them for the life of that bearing. It operates through the life without maintenance.
All right. So you talked about the potential, and of course, that's not the immediate thing that we're thinking of. We're thinking of making the system robust. Uh, However, given that it provides sustainability, and which is increasingly becoming a very critical factor in industrial growth. How do you see SKF's role in integrating sustainability into commercial and industrial strategies, not only in India, across Southeast Asia and NZ, where you are also involved? And could you also provide some examples of innovations that have been done to meet environmental goals?
Yeah, sure, and I'm glad you brought this up, because if you look at our purpose, it's we reimagine rotation for a better tomorrow. So a big part of our purpose is a better tomorrow, and there is no better tomorrow if you don't think about sustainability as a goal. So sustainability is at the center of a lot of things we do, and there are two parts to it. One is when we run our own operations, so making sure, for example, that we're on as much clean energy that we can be, making sure we have the least energy wastage possible. So that's on the operation side. But I think for our customers, where we bring solutions, I'll take a couple of examples. The first one is, we do remanufacturing, right? So, and we're going, whether it's Australia, whether it's India, whether it's Southeast Asia, we're going to more and more customers and providing them with a solution now to remanufacture their bearings, which would reduce their cost by 50%, but more importantly, it would reduce carbon dioxide emissions by 80%, right? So the same bearing, let's say it had a life of about 4 years, you can remanufacture in a lot of cases 2 times, which means now you improve that life to 12 years, right, from 4 years. And it's a lot of CO2 emissions that you're saving. So that's one example. Another example I'll give you is recond oil, right? So we've got a technology called recond oil where a lot of the lubrication oil that's used in any manufacturing plant, the oil gets contaminated and then the oil needs to be let out and you need to refill new oil. But we've got a closed system where you can use the same oil. It filters the oil to multiple degrees and makes it as good as new, which means you can just recirculate the same oil again and again without having to have like an input and output for oil. So again, saving a lot of oil consumption and spillage there. So these are a couple of examples, and we have a lot more because this is really one of the core things that we keep in mind when we're developing products.
That's great to hear because all this is not only leading to a sustainability, it's also making it cost effective, which is very important because increasingly we have seen it with solar, we have seen it with wind, that increasingly as it becomes more and more cheaper, the adaptability goes up. All right. That's good to hear that, you take care of individual requirements. I think that's very important. And the other part about SKF strategy, I'm very happy to hear that, you're not dependent on one sector. So that makes you a kind of shock-proof to economic turmoils anywhere. So thank you so much, Sujith, for joining us. It was great interacting with you. And I believe this new sector that you're developing and working on will bear fruits for not only India, but across the world in terms of energy sustainability. Thank you for joining.
Thank you so much.